Okay, by the end of this session, I will know why objects go round in a circle, be able to explain the importance and work out the size and direction of the centripetal force acting on an object, and understand the centripetal force affects the direction of the velocity of an object orbiting a point, and therefore causes an acceleration which can be found by A equals v squared divided by r, which equals r omega squared. Newton's first law of motion states that an object will remain at rest or continue to move with a uniform velocity unless acted upon by an external resultant force. Okay, for all those people out there that noticed something odd about that statement when it appeared on the screen, well done, you're paying attention. For those of you that don't know what I'm talking about, there are 6 grammatical or spelling mistakes in this statement. It's important that you pay attention to not only what's being said during these sessions, but to the written work as well. Let's look at an example of circular motion. If we watch the marble going round in the record player, a record, by the way, is something that music used to come on before CDs. They're old and black and made out of vinyl, and you put a needle on top of them and you played music. If we look at the marble, we can see that it keeps changing direction. Let's stop the film in 3 places to show this. You can see that the direction of the velocity, remember velocity is a vector quantity and has to have size and direction, keeps changing. For this to happen, an external force must be acting upon the marble. This force changes the direction of the velocity and is known as the centripetal force. It acts at right angles to the velocity, pointing directly towards the centre of the rotation, like so. This centripetal force keeps the marble moving in a uniform circular motion around a fixed point at the centre of the record player. So we know the marble changes direction, and we also know Newton's first law. So let's put these together. The resultant force acting on the marble are making its direction change. The magnitude of its velocity is the same, but the direction keeps changing. This means the resultant force acting on the marble are causing it to accelerate towards the centre of the record player. This force, the force causing this acceleration, is known as the centripetal force F. As you've seen in previous sessions, we can find out how fast the marble is actually travelling by finding its angular speed. The angular speed is found by the velocity divided by the distance the marble is from the centre point. The angular speed is measured in radians per second. Remember that 1 radian is about 57 degrees, and there are 2 pi radians in one circle. So we can also calculate the angular speed by omega equals 2 pi times the frequency of rotation. So omega equals 2 pi f. Have a go at the questions on the next slide to check your understanding.